The overall goal of this experiment is to measure the 3D trajectory for a catalytic swimming device.
This technique can help explain a variety of phenomena for swimming devices, such as how they respond to chemical gradients and gravitational fields while they're moving in bulk solutions. A key advantage for this technique is that it can be applied using any conventional fluorescence microscope. This technique will be demonstrated by my PhD student, Richard Archer.
For this protocol, prepare glass slides as described in the text. Next, prepare the colloidal dispersion for deposition on the slide. First, pipette 10 microliters of aqueous 10% by weight fluorescent colloid solution into 990 microliters of ethanol for a 1 milliliter 0.1% by weight colloidal suspension. Then, vortex the mix for 10 seconds. Next, spin coat the colloidal dispersion onto the prepared glass slide substrate. Prepare to load 100 microliters of the diluted colloidal solution onto the slide. Once at 2000 RPM, gradually deposit the suspension onto the center of the slide. Spin for 30 seconds from the start of the deposition. Transfer the coated glass slide to an optical microscope and verify that an even dispersion of mostly non-touching separate colloids covers the central region of the slide. Next, vacuum evaporate platinum metal onto the glass slide in a metal evaporator. Make certain to load the slide with the colloids facing the evaporation source. Use a platinum metal evaporation source and deposit 15 nanometers of platinum.